Aluminum fluoride ionic, but aluminum chloride is covalent in nature. But why? This is what we are going to learn today. So let's get started. Aluminum fluoride is ionic in nature, but aluminum chloride is covalent in nature. Why? First of all, let us see position of fluorine and chlorine in the periodic table. Fluorine and chlorine, that means halogens, belong to column 17 in the periodic table. Fluorine, chlorine, bromine, iodine, astatine, and finally tennessine, halogens that belong to column 17 in the periodic table. Now let us see atomic size of these elements. Fluorine, nucleus, this is atomic size of fluorine. Then chlorine, which is a bit bigger than fluorine. Then bromine, which is more bigger than chlorine. Then iodine, which is bigger. That is, atomic size increases from top to bottom. Atomic size increases down the group. Again, we know elements that belong to a specific column are almost similar in properties. That means compound of fluorine with aluminum fluoride, which is solid under normal condition, then compound with aluminum of chlorine, which is aluminum chloride. This is also solid under normal condition. As these elements are almost similar in properties, these compounds should be similar, but not exactly similar. Aluminum fluoride is ionic in nature and aluminum chloride is covalent in nature. Because of this, aluminum fluoride boils at 1291 degrees Celsius temperature. As this is ionic in nature, so its boiling point is higher. But aluminum chloride is covalent in nature. For this reason, it boils at low temperature. That is 192 degrees Celsius temperature is boiling point of aluminum chloride. So aluminum fluoride and aluminum chloride are not similar. Why? This is what we are going to learn today. Simply, why aluminum fluoride ionic in nature and why aluminum chloride covalent in nature. Let us enter into the matter. Hydrogen, a complete covalent compound. This is structure formula. Electrons in the middle of these two atoms. This can be showed in this way as electron cloud. When a compound is completely covalent compound, electron cloud remains exactly in the middle of these two atoms. But when a compound is ionic compound, then electron cloud remains around an ion. In ionic compound, electron cloud remains around an ion. In this way, simply we can imagine in this way. But somehow, when this electron cloud moves to any of the atoms, then this compound turns into ionic in nature. Similarly, when this electron cloud moves to cation, then it turns into covalent in nature. Again, when covalently bonded electron cloud moves to any of the atom, this compound turns into ionic in nature. In case of ionic compound, when this electron cloud moves towards ion due to the attraction of cation, then this ionic compound turns into covalent in nature. Now, let us see about aluminum fluoride. This is basically ionic compound. Aluminium 3 plus ion, fluoride ion, fluoride ion, fluoride ion. Then aluminum chloride. This is as well basically ionic compound. Chloride ion, fluoride ion, fluoride ion. Here, aluminum 3 plus ion causes polarization of fluoride ions. Here as well, aluminum 3 plus ion causes polarization of chloride ions. But we know fluorine is smaller in size. This is electron cloud around fluorine or fluoride ion, and this is chloride ion, which is a bit bigger in size, and this is electron cloud of chloride ion. In case of fluoride ion, we see the distance between electron cloud and nucleus is less than the distance between nucleus and electron cloud. That is, in case of fluoride ion, electron cloud is strongly bonded to the nucleus due to the less distance. But in case of chloride ion, electron cloud is comparatively loosely bonded to the nucleus due to the more distance compared to fluoride ion. So, in case of aluminum fluoride, less polarization occurs. In case of aluminum fluoride, less polarization occurs. What is polarization? Polarization is distortion or movement of electron cloud of an ion due to the attraction of cation is called polarization. So here we observe polarization. In case of aluminum fluoride, less amount of polarization occurs because here fluoride ion holds its electron cloud strongly because of this less distance here. In case of fluoride ion, electron cloud is strongly bonded to the nucleus of the fluorine. For this reason, here less polarization occurs. Movement of electron cloud of anion towards cation is called polarization. So, aluminum fluoride retains its ionic nature due to the smaller size of fluoride ion. That is, here very less polarization occurs. This is movement of electron cloud, which is very less in case of aluminum fluoride. For this reason, aluminum fluoride retains its ionic nature. But in case of aluminum chloride, we know fluoride ion is bigger in size compared to fluoride ion. And here, electron cloud is loosely bonded to the nucleus because of this higher distance. For this reason, in case of aluminum chloride, polarization occurs to a great extent. Polarization occurs to a great extent. That is, here, in case of aluminum chloride, electron cloud moves to the aluminum 3 plus ion to a great extent. That is, here high polarization occurs. Because of this high amount of polarization, aluminum chloride turns into covalent in nature. So, due to less polarization, aluminum fluoride retains its ionic nature, but due to high polarization, aluminum chloride loses its ionic nature, and at the same time aluminum chloride attains its covalent nature. So, due to low polarization, very low polarization, aluminum fluoride is ionic in nature, and due to high polarization, aluminum chloride is covalent in nature. And we know melting point, it will be melting point. Melting point of ionic compounds is higher and melting points of covalent compounds is lower. So, ionic compound, that is aluminum fluoride, melting point is higher, and covalent compound, that is aluminum chloride, melting point is lower. So, aluminum fluoride, which is ionic in nature, but aluminum chloride is covalent in nature. Thank you for watching.